People often ask me, how do you know how to do problems? Or how do you know what equation to use? And I say, I don't know, it's kind of hard. But here's 3 ways that you can approach thinking about it. So for example, this problem, you can think about it intuitively. We know that the longer you travel, the farther you're going to go, and the faster you're traveling, the faster the velocity, the farther you're going to travel. So we know that the distance of your travel is proportional to both 11 seconds and 3.5 meters per second. So it kind of makes sense to multiply these together. And that would be what you are supposed to do. But that doesn't always work, an intuitive approach. A lot of times we'll have to find an equation that has, well, first of all, the variable in it that you're trying to solve for, which in this case would be displacement. So that is, so we'd have to recognize that how far we travel is a difference in position, which is a displacement. And if it's an easy problem, then we can identify what else is given in the problem. So 11 seconds is an elapsed time. So we've been given delta t, and 3.5 meters per second, that's an average velocity. So we can identify what other variables are given, and hopefully there'll be an equation with the variable we're solving for and just these other 2 variables. And in this case, yeah, there is. It's one of the simplest equations for motion. Average velocity equals displacement over elapsed time, and we just saw that we can solve that for displacement. And we have the equation displacement equals average velocity times elapsed time. Then we can just put in the numbers that were defined for those variables. And then plug those numbers into the calculator and get our answer. Another way to think about it is in terms of the units. We want meters, which is a displacement. We are given, what are we given? Seconds, the time, and we're also given the velocity in meters per second. So we have to do operations on seconds and meters per second in such a way that the units will cancel to give seconds. And we can see that if we multiply these 2 units by each other, we will end up getting meters per second times seconds, a seconds on top divided by seconds on the bottom, and that unit will cancel and we'll be left with just meters, which is what we want. So just thinking about the units and how they cancel also indicates that we should multiply the velocity times the time. But that's not actually usually going to be a great approach to figuring out what to multiply by what. As we'll see, with the more complicated equations coming up this chapter, looking at the units and how they cancel is really something you should use to check whether you've used the correct equation and use that equation correctly. You should be able to put in units for each number in the equation and multiply and divide those units as dictated by your equation, and you should find that the units of your answer are appropriate for that answer. If you're trying to find time, your unit should be seconds. If you're trying to find a velocity, it should be meters per second, etc. And an acceleration, that's the tricky one. When you're working in SI units, the acceleration should be in meters per second squared, or meters per second. And intuition is also, better used as a way to check whether your answer is reasonable. You should always do a reasonability check at the end of a problem. if we'd come up with an answer of 5 billion meters for this problem, it should ring alarm bells that that's not probably what's actually going to happen if somebody's traveling a very slow 3.5 meters per second for only 11 seconds.
Made with Doodlecast Pro.